a student can be able to do, what a student can do, what a student can able to do. Uh, and in addition to that, we have also discussed about what is analog signal and what is digital signal. Now I give you one problem. Here I draw the two signals. One signal is like this. This is x1 of t. Okay. This is a sinusoidal signal. The maximum value is 1 and minimum value is -1. I draw the another signal also. Here also this is x2 of t, 1 -1. Now you tell me which one is analog signal and which one is digital signal. Which one is analog signal and which one is digital signal?
First one, analog signals.
First one means x1 of t.
X1 of the analog.
X2 of t digital signal.
Digital.
X2 of t is the digital signal. You see here, what is the range of amplitude of x1 of t between -1 and +1, no?
Yes,
and
sir.
here the range of x2 of t is also -1 to +1. The difference between these two. Here the range of x1 of t is also -1 to +1, similar to x2 of t. The range of x2 of t is also -1 to +1. What are the possible values of x1 of t at any instant of time? What are the possible values of x2 of t at any instant of time?
For x1 of t is infinite.
X1 of t is having infinity possible values. Can you tell me one example? Suppose the value of x1 of t may be 0.8763, or the value of x1 of t will be -0.5232. Do you agree there are infinity possible values between -1 and +1?
Yes, sir.
Here, what are the possible values of x2 of t at any instant of time? What are the possible values of x2 of t at any instant of time?
-1 or +1.
-1 or +1. So, suppose at this at discontinuity, the value is not defined, cannot be defined, of course.
Okay.
But except discontinuities, the value of x of t will be either 1 or -1. No other value.
Okay.
No other values of x of t exist. So x of t is a digital signal. X of t is a digital signal. This is analog signal. Analog signal. Okay. Here I draw the another signal. Suppose this is x3 of t. What is this signal?
Digital, sir.
Digital signal.
It is
A digital signal.
digital signal. Sure. Digital signal. Okay. Then what are the possible values of, suppose these values are 1, 2, 3. Then what is the name of this signal? What is the name of this signal?
4-array digital signal.
4-array digital signal. Very good.
Digital signal.
4-array digital signal. 4-array digital signal. How many possible values extra of t can have?
4 values.
4, sir.
What are those values?
0, 1, 2, 3.
0, 1,
At
2,
any
3.
instant of time, the value of extra of t will be either 0 or 1 or 2 or 3.
2 or
No other values. Then what are the predetermined values? 0, 1, 2, 3.
2, 3.
This is the set of the values. This is the set of the values. Okay, 0, 1, 2, 3. Okay, so this is about analog and digital signal. I'm very happy. You are very well known about analog and digital signals. Now we come to the second unit. So what will you learn in the first unit? Yesterday we have discussed. You will learn about different coding techniques, no?
Different techniques of pulse
Coding techniques. What are
modulation.
those coding techniques?
Pulse digital modulation.
Pulse code modulation. What are those techniques? Pulse code modulation, differential pulse code modulation, and delta modulation. So, after completing the first unit, you will be able to know. You will be able to answer these questions. What are the different waveform coding techniques for the representation of digital signals? Okay, you are in a position to answer this question. The answer is PCM, DPCM, DM. And what are the effects of noise in these techniques? So if noise presents, then what is the effect of these coding techniques? Okay, you will know about information about noise in these techniques. Next, you will be in a position to calculate the bit rate, bandwidth, and signal to noise ratio of these different coding techniques. Suppose you speak in front of microphone. That microphone converts our voice signal into electrical signal. Now that electrical signal is transmitted. Suppose you are establishing a digital communication system such that your voice signal is converted into a digital signal by using PCM. Then the question is, then what is the data rate? At what data rate that signal is transmitted? What is the bandwidth of the channel that is occupied by the communication system? What is the signal to noise ratio? That is, what is the quality of that signal? So for all these questions, you can answer after completing this first unit. Okay. And next class, I will ask you questions. Okay, you write whatever you listen to the this class. Okay. Next, coming to the second unit. What is the course outcome? One, you are in a position to analyze the performance of different waveform coding techniques for the representation of digital signals. Next, second unit, digital modulation techniques. Digital modulation techniques. Now, what is the difference between first unit and second unit? That is pulse digital modulation. This is digital modulation techniques. You don't confuse, both are modulation techniques. This is also modulation technique. This is also modulation technique. But in the first unit, the pulse digital modulation The main purpose of this pulse digital modulation technique is to convert an analog signal into digital signal. That's all. Analog signal into digital signal. Once you convert the analog signal into digital signal, now you are supposed to transmit this digital signal from one point to another point. No? From one point to another point, you are supposed to transmit this signal. Now, for that purpose, we study the digital modulation techniques. In the analog communication, we have studied different modulation techniques. What are those modulation techniques? Amplitude modulation technique, frequency modulation technique, and phase modulation technique. Of course, frequency modulation and phase modulation come under angle modulation. So basically, there are two types of modulation techniques: amplitude modulation and angle modulation. Okay. Why modulation is performed in that case? The message signal has generally audio signal. All the audio signals occupy the same frequency range. If all audio signals are transmitted, then at the receiver, it is not possible to separate these signals, one signal from another. So for that purpose, we perform the modulation technique. Then what is the modulation? Modulation is a technique such that the spectrum of message signal is shifted to the another spectrum. The low frequency spectrum of the message signal shifted to the high frequency spectrum. High frequency spectrum. So so that the modulation is performed. In addition to that one, then the size of antenna is also another factor, because the audio signals have low frequency range. So the height of the antenna is directly proportional to the frequency. So they must be proportional to the frequency. So if frequency is increased, then height of the dimensions of the antenna can be reduced. So like that, so many advantages we have discussed. What is the necessity of modulation? Similarly, here also, you have a digital signal in your hand. Now, our duty is to transmit this digital signal from one point to the another point. From one point to the another point. Okay? Transmit this digital signal from one point to the another point. Now, the question is that whether you transmit this digital signal directly or with modulation. If you transmit that digital signal directly, that is called baseband communication. Baseband communication. If you transmit that signal, that digital signal after modulation, that communication is called band pass communication. Why band pass communication? The digital signal is when it is modulated. Just now I told you, the frequency spectrum of that digital signal is shifted to the high frequency range. No? So before modulation, the frequency spectrum is low frequency. After modulation, the frequency spectrum is occupies band pass, band of frequencies. So that's why we can say that is band pass communication. So in this unit, we will learn about what are the different modulation techniques. What are the different modulation techniques that can be utilized to modulate the digital signal, that are ASK, FSK, PSK, DEPSK, DEPSK, like that. So many 2PXSK, so like that. So in the second unit, we will discuss about the different modulation techniques that are used to modulate the digital signal. What is ASK? Amplitude shift keying. It is similar to the amplitude modulation for analog communication. Similarly, FSK, frequency shift keying. That is similar to the frequency modulation for analog communication. And PSK, phase shift keying, that is similar to the phase modulation for analog communication. And these are the basic three modulation techniques: amplitude shift keying, frequency shift keying, phase shift keying. So here also modulation as the same definition. What is modulation? We take the carrier. One of the characteristics of the carrier is varied according to the modulating signal. Okay, this is the modulation. No? In analog communication, we have amplitude modulation and angle modulation, frequency modulation and phase modulation. No? What are the definitions of these modulation techniques? We take the carrier, high frequency carrier. The amplitude of the carrier is varied according to the modulating signal. That is amplitude modulation. Similarly, here also same. We take the carrier, same. We take this sinusoidal carrier. We take the sinusoidal carrier. As we have taken in the analog communication, the carrier is same. Whether analog communication or digital communication, the carrier is high frequency sinusoidal signal. High frequency sinusoidal signal. Now, the high frequency sinusoidal signal carrier has three characteristics: amplitude, frequency, and phase. Amplitude, frequency, and phase. Now, the amplitude of the carrier is varied according to the digital signal. That is called amplitude shift key. If the frequency of the carrier is varied according to the digital signal, the value of the digital signal, that is called frequency shift key. If the phase angle of the carrier is varied according to the value of the that digital signal, then that is called phase shift key. Then why we use keying term here? Because a digital signal has only two values. Generally, we take the digital signal as a binary signal. The digital signal has only two values. Suppose this is the digital signal. I transmit 1 0 0 1 0 1 1 0. Suppose it is the sequence of bits that is to be transmitted. That suppose 1 is represented by 5 volts and 0 is represented by 0 volts. Then 5 0 again 0 again 1 again 0 again 1 again 1 again 0. So this is the signal. This is the signal that is this is the signal that is to be transmitted. That is to be transmitted. Okay. Here I take the carrier, high frequency carrier, high frequency carrier. High frequency carrier. Here this high frequency carrier, has amplitude as well as frequency as well as phase angle. No? If the amplitude of the signal is varied according to the value of the digital signal. Here according to the value of the digital signal means that the digital signal has only two values. No? That the digital signal has only two values, either 1 or 0. 1 means 1 is represented by suppose 5 volts and 0 is represented by 0 volts. So that digital signal has either 5 volts or 0 volts. So here suppose the amplitude of the carrier is varied according to digital signal means the amplitude of the carrier will be having only two values. One value is due to this 5 volts, another value is due to this 0 volts. Am I correct? One value is due to this 5 volts, another value is due to this 0 volts. Whereas coming to the analog the amplitude modulation, there also the amplitude of the carrier is varied according to the amplitude of the message signal. There, the message signal is a analog signal. The message signal is a analog signal like this. The message signal is analog signal. Okay. Here the amplitude of the message signal is not having only two values. It has infinity values. No? It has infinity values. So many values are there. So if the amplitude of the carrier is varied, according to the message signal, this amplitude of the message signal, then amplitude of the carrier having many values. But here in the digital modulation, the amplitude of the carrier is varied according to digital signal, means the digital signal has only two values. That's why we use the word keying. Amplitude shift keying. That means the carrier of the amplitude of the carrier has two values. One value is due to logic 1 and another value is due to logic 0. Okay, so that's why we say that keying, it is varied between two values only. The amplitude of the carrier is varied between two values. Okay, next, frequency shift keying. Can anybody tell me what is frequency shift keying? Amplitude shift keying means amplitude of the carrier is varied according to the digital signal. Amplitude of the digital signal. What is the frequency shift keying?
Frequency is varied according to the
Frequency of the carrier.
varied.
Yeah, very good. Frequency of the carrier is varied according to the
Digital signal.
digital signal means amplitude of the digital signal. Okay. So after modulation, that FSK is having how many values? How many values? Two values, no?
Two values.
One frequency is due to the logic 1, another frequency is due to the logic
0.
Okay. When the digital signal is logic 1, then FSK is having suppose 10 kHz. And digital signal is logic 0, FSK frequency is 5 kHz. So at any instant of time, the carrier frequency is either 10 kHz or 5 kHz. Am I correct? Either 10 kHz or 5 kHz. Okay, like that. Next, PSK, phase shift key. Can you define what is phase shift key?
Phase of the carrier is
Very good. Phase of
varied
the
according to the digital signal.
Yeah, amplitude of the digital signal. Okay, value of the digital signal. Now, can you tell me how many phase values it has?
Two phase values.
How many phase values?
Two phase values.
Yeah, very good. Two phase values. It has two phase values. Suppose the two phase values are 0 degrees and 180 degrees. 0 degrees is associated with the logic 0. 180 degrees is associated with the logic 1. For example, it is not fixed to the such that 0 degrees is associated with 0 degrees is associated with maybe 0 or logic 1. That doesn't matter. Okay, 180 degrees is associated with logic 1, like that. Okay. Similarly, now these are extensions of these topics. DPSK, differential phase shift key, differential encode PSK, QPSK, quad PSK, MRI PSK, ASK, FSK, similarity, like that. So anyhow, in the first unit, you will be able to, what is the outcome of the second unit? Analyze the, you are in a position to analyze the performance of digital modulation schemes, performance of the digital modulation schemes, and choose appropriate modulation schemes according to design criteria. Okay, so you will analyze the performance of digital modulation schemes. What are the digital modulation schemes? What are the digital modulation schemes?
Amplitude shift key, phase shift key, frequency.
Yeah, very good. ASK, FSK, PSK. So you will analyze the performance of each modulation scheme after completing this unit and choose appropriate modulation schemes according to design criteria. So because ASK is having some advantages, FSK is having some advantages, PSK is having some advantages, like that. According to the design criteria, you can choose which modulation is suitable. Okay, that is about second unit. Okay, let us see first again about 2 units. In the first unit, what will you learn? You will learn about what are the different waveform coding techniques. What are the waveform coding techniques? What are the different waveform coding techniques? PCM, DPCM, DM. Okay. Then what is the purpose of these waveform coding techniques? How an analog signal is converted into digital signal. How analog signal is converted into digital signal. So in the first unit, briefly we can say that you can you will learn about how an analog signal is converted into digital signal. Next, once you have digital signal in your hand, how this digital signal is modulated. How this digital signal is modulated. That is studied in the second unit. Okay. Next, coming to the third unit, data transmission. Okay. Now, first unit, in the first unit, how analog signal is converted into digital signal. Okay, that is completed. Now you are with the digital signal. Now you have studied how that digital signal is modulated in the second unit. Okay, after second unit, you have a modulated digital signal. Now that modulated digital signal is to be transmitted to the receiver. No? So that data transmission topics will be discussed in the third unit. That topic will be discussed in the third unit. You just have a look on topics of third unit: baseband signal receiver, probability of error, the optimum filter, matched filter, probability of error using matched filter, coherent reception, coherent reception, non-coherent detection of FSK, calculation of error probability, like that. Okay. I will tell you a brief note on the third unit. Baseband signal receiver. Baseband signal receiver. So once the signal is modulated, signal is transmitted, whether you transmit modulated signal, that is band pass signal, or whether you transmit the digital signal directly. You see, if you transmit digital signal directly, that is called baseband communication. You please note down. If you transmit digital signal directly, that without modulation, that transmission is called baseband communication. If digital signal is modulated, then it is transmitted, then it is called band pass communication. Whether it is modulated or directly transmitted, but finally at the receiver, what is your job? What is the job of receiver? The job of receiver is to receive the digital signal, and it should be in a position to identify whether the signal received is logic 1 or 0. Logic 1 or 0. So that is the biggest advantage of digital communication. Whereas in analog communication, the signal is transmitted. The analog signal is transmitted. The analog signal, suppose it is between -5 volts to +5 volts. It is between -5 volts to +5 volts. Now that signal is transmitted. At the receiver, when the receiver receives the signal, suppose it receives the signal of 4.5 volts. It doesn't know whether the signal transmitted is equal to 4.5 volts or it is actually 4 volts and 0.5 volts noise is added, or it is actually 5 volts or -0.5 volts noise is added. So we cannot predict, because between -5 to +5, that analog signal is having infinity possible values, no? So at the receiver, whatever the signal it is received, that signal, in that signal, what is the part of the noise that cannot be predicted? That cannot be predicted. It is somewhat difficult to predict that noise. Of course, some techniques are there to avoid that noise in analog communication. Let it be. Now coming to the digital communication. In digital communication, what will happen? You are transmitting either logic 1 or logic 0. You are transmitting logic 1 or logic 0. Suppose logic 1 is represented by the +5 volts and logic 0 is represented by the -5 volts. Now this signal is transmitted with the modulation or without modulation, whatever it may. Finally, we get digital signal at the receiver. So at the receiver, suppose receiver receives the 3 volts. Receiver receives the 3 volts. Then it easily detects that, okay, logic 1, that is 5 volts is transmitted, maybe minus 2 volts is the noise, so that that signal is related to the logic 1. Okay, there are only 2 possibilities now. The transmitter transmits either logic 1 or logic 0, either plus 5 volts or minus 5 volts. If you receive plus 5 volts, okay, you are happy. That receiver identifies that is related to the logic 1. If minus 5 volts is received, then receiver identifies that it is related to the logic 0. Suppose any value between minus 5 volts to plus volts is received by the receiver, then in that receiver will decide, the receiver will decide whether that voltage is related to the plus 5 volts or minus 5 volts. Suppose 3 volts is received, then which is related to the plus 5 volts or minus 5 volts? In which case probability is more. Suppose the receiver receives the 3 volts. That 3 volts is related to the plus 5 volts or minus 5 volts. Can you say that it is definitely 100% it is related to the 5 volts? No. Probability is more. Probability is more. Maybe 5 volts is transmitted and 2 volts is minus 2 volts is the error. So that that receiver receives the 3 volts. Another possibility is also there. Huh? What is another possibility? Suppose receiver transmits the minus 5 volts and minus 5 and 7 volts noise is added. 7 volts is noise is added. Sorry, 8 volts noise is added. Then minus 5 plus 8. What is the voltage? 3 volts. That is also one possibility. What are the 2 possibilities? In one possibility, transmitter transmits the plus 5 volts, that is logic 1, and the noise is minus 2 volts, so that the receiver receives the 3 volts. What is another possibility? Transmitter transmits the minus 5 volts, and that is related to the logic 0, and noise is around 8 volts, then minus 5 plus 8 is equal to 3 volts. There are 2 possibilities, but in which case possibility is more, probability is more? Logic 1 or logic 0? Any one of you? అర్థమవుతుందా? In which case the probability is more? సార్ మీరు నాకు ఎందుకంటే ఎదురుగా కనిపించరు కదా, మీరు ఏదో ఒకటి మాట్లాడాలి. చెప్పండి, ఆన్సర్ చెప్పండి. మీకు అర్థమైందా? మళ్ళీ ఒకసారి రిపీట్ చేయాలా?
ఒకసారి మళ్ళీ రిపీట్ చేయండి సార్.
ఇప్పుడు in analog communication, this signal is transmitted. This signal is transmitted, whereas in digital communication, this is 5 volts minus 5 volts. Here also maximum 5 volts, minimum minus 5 volts. Okay. So particularly in analog communication, suppose at this time, particularly at this time interval t naught, 4.6 volts is transmitted. 4.6 volts is transmitted. At the receiver, it receives the 4.9 volts. Then receiver is not able to identify whether the transmitter transmits the 4.9 volts and the noise is 0, and the transmitter transmits the 4.6 volts and noise is 0.3 volts, or transmitter transmits the 5 volts and the noise is minus 0.1. It cannot predict. Am I correct? Or no, the transmitter transmits the 3 volts and noise is 1.9. 3 plus 1.9 is equal to 4.9. It cannot predict. Whereas suppose in digital communication, suppose at a particular instant of time, it transmits the logic 1, which is related to the 5 volts. It transmits 5 volts. At the receiver, you receive the 3 volts. It receives the 3 volts. Then here, then receiver can understand that, okay, the transmitter may transmit the logic 1, 5 volts, and the noise is, it transmits the 5 volts, and noise is minus 2 volts. So that I get 3 volts. That is one possibility. And another possibility is that the transmitter transmits the minus 5 volts, and noise is 8 volts. Noise is 8 volts. So that I get, receiver gets the 3 volts. Only two possibilities, no? In digital communication, no other possibility, because either transmitter transmits the plus 5 volts or minus 5 volts. The receiver receives the 3 volts only. So if the transmitter transmits the 5 volts, noise might be minus 2 volts. If transmitter transmits the minus 5 volts, the noise might be 8 volts. But here, if receiver receives the 4.9 volts, what is the transmitter? What is the voltage transmitter? The transmitter is not predictable. There are so many possibilities. One possibility is that transmitter transmits the 5 volts and the noise is 0.1. Or the transmitter transmits the 4.6 and noise is 0.3. Actually, the transmitter transmits the 4.6. And transmitter transmits the 2 volts and noise is 1.9. So many possibilities are there, no? So many possibilities. So the receiver is not able to predict what is the signal transmitted by the transmitter. It assumes that the signal is 4.9 volts. But here, there are only two possibilities. Okay? Then suppose receiver receives the 3 volts, that this probability is more or this probability is more. Which probability is more? Now you answer the question. If a receiver receives the signal of value 3 volts, the transmitted signal will be 5 volts or minus 5 volts. Which one is higher?
5 volts.
5 volts.
5 volts.
5 volts.
5 volts. Now it is definitely anybody can tell that. Maybe the noise may be minus 2 volts. But this also has the possibility. Second case also has the possibility. But that possibility is very less, no? That possibility is very less. That possibility is very less. Okay. Very good. Next, suppose really transmitter in digital communication, really transmitter transmits the logic 1, that is 5 volts. But the receiver receives the 3 volts. The receiver receives the 3 volts. The receiver is the receiver intelligently detects that, okay, 3 volts is transmitted. There are more possibilities that 5 volts is transmitted. Then it can understand that the received signal is logic 1. The received signal is logic 1. Okay. And suppose really the receiver transmits the 0 volts, that is minus 5 volts, and noise voltage is 8 volts, like this. Noise voltage is 8 volts, and the receiver is 3 volts. But immediately it detects that logic 1 is transmitted. Logic 1 is transmitted. Okay. Suppose 0 is transmitted, then it detects as a logic 1. Then there is error. There is a error. There is an error. Actually, 0 is transmitted. Even the least possibility is there. కొన్ని కేసులు అలా అవ్వచ్చు కదా, లీస్ట్ పాసిబిలిటీ ఉన్నా కూడా అంటే మనకి హైయెస్ట్ పాసిబిలిటీ ఉన్నదే గ్యారంటీ 100%. సపోజ్ ఇది 100% పాసిబిలిటీ అనుకోండి, అది ఎప్పుడు కరెక్ట్ అవుతుంటుంది. Suppose it is 80% possibility and 20% possibility, then what happens in these cases? 10 అందుకే మీకు చెప్పాను, నిన్న చెప్పాను, random variables and probability theories knowledge is very essential. Suppose these cases occur 100 times. Do you agree that 100 times logic 1 is received is correct? No, 80% maybe. Suppose possibility is 80%. 80 times you are correct, but 20 times you are not correct, no? Like that. Maybe 0 volts is 0 logic is transmitted. Unfortunately, minus 3 volts is received. Then the receiver generally treat this voltage as a logic 1, but there is an error. Okay, that is called probability of error. Now, do you understand probability of error? That you may get, suppose logic 1 is transmitted. If receiver receives the logic, same logic 1, there is no error. If logic 0 is transmitted and receiver receives the as a logic 0, then there is no error. If 1 is transmitted and it receives as a logic 0, and 0 is transmitted, it receives as a logic 1, in that case, there is an error. Then what is the probability of error? So that concept is studied in this third unit. Okay, next, optimum filter and matched filter means in the receiver we use the filters. Such that the probability of error should be less. So for that purpose we use the matched filter and optimum filter, like that. And the probability of error using matched filter, coherent reception, non-coherent detection, calculation of error probability of ASK, BPSK, BFSK. So ASK, BPSK, BFSK are studied in the second unit. No? BPSK means binary phase shift keying. It is same as phase shift keying. Okay. These modulation techniques, when you use this modulation technique, what is the probability of error? Suppose if you use amplitude shift keying, what is the probability of error? If you use phase shift keying, what is the probability of error? All these will be studied in the third unit. So what is the outcome of third unit? You will be able to calculate bit error rate or probability of error. Both are same. Probability of error, bit error rate for baseband signal receiver and various digital modulation schemes. Okay. So after completing the third unit, if you are in a position to calculate the probability of error or bit error rate for a different modulation techniques, then you have studied that. Okay. Next, coming to the fourth unit, information theory. Fourth unit, information theory. 10:30. Okay, exactly. So we will discuss in the next class.